Our next presenter is not walking out the door. He's going to stay here and present. Mr. Douglas Inglis, who is a graduate student from Texas A&M University, and he will be talking about the sail plan and the rigging of the Warwick in the context of general 17th century sail. So here is Mr. Douglas.
Okay, I'd like to thank everybody who came back to enjoy the second half of our marathon session today. I'm going to be talking about Warwick's rigging. Now, a caveat to begin with. We have a very small artifact assemblage. Currently, we have a number of iron artifacts. None of them have been conserved yet, so we're still getting data from them. Secondly, we have a lot of wooden artifacts, but those are all going back through reconservation. And third, a lot of the data that we need to reconstruct the rigging and the sail plan is tied up in finally determining the size of the hull. But what I can provide for you today is an overview of the artifacts that we do have. And I think we have a very small but unique assemblage, and I'm going to try to not only show you those artifacts, but sort of explain the context that they belong in. So let me begin. It may be that Warwick's rig is ultimately responsible for her demise. Two ships weathered this storm in Castle Harbor, Warwick and Garland. Now, the crew of the very small Garland were either able to remove her mast ahead of time or cut it down in the midst of the storm. Warwick's mast, on the other hand, stayed up, and either wind or fate drove her into the reefs. She came to rest in a very shallow grave, and this is very important for the site formation process. She was listing over on her side. This made it very, very possible to salvage the wreck and get access to those rigging elements. We have reports of Butler taking off rope and sails, and very much indeed, they would have harvested absolutely everything they can. Bermuda is, at this point in time, sort of a wood and industry poor island. And you didn't have access to a lot of the more high-tech rigging materials and ropes. So these would all be very valuable, particularly for re-rigging ships such as Garland, who was damaged during the storm, and also the Treasure, which was sitting at anchor and rotting. So what was left behind? Butler and his crew, and according to Butler's accounts, the embezzling Bermudans, who also went and looted everything they could off the wreck, stripped everything they could clear. We're left with things that were tossed off in the storm, items that were too securely fixed to the hull to be removed, or things that were too deep for the salvage divers to get after. What we discovered in the past couple of years are a number of chain plates, and these are beautiful examples of 17th century chain plates. They're very rarely preserved in the archaeological record. Two of them, these two here, are sort of in place, almost in situ. I'll describe why this is a little complicated later in the presentation. We also have a number of blocks and deadeyes. Now, we didn't salvage these. These came up in the 79 and 80 excavations that were carried out by Tucker. And a lot of them are in sort of deteriorating condition right now, and hopefully they're going to be going through a process of reconservation at the National Museum of Bermuda. What I'm going to do is I'm going to try to look at these artifacts individually, and then I'm going to put them into the context of some fairly well-known 16th century and 17th century wrecks. So let's first look at the ship's standing rigging. Standing rigging are the ropes and the system of ropes that are used to support the mast. We're looking right here at the stays, which pulled the mast forward and down, and also we're looking at the shrouds and the swifters and the tackles, which serve to pull the mast to the side and backwards, as well as backstays. To kind of get an idea of what she looked like, we need to turn to treatises, such as the 1625 treatise on rigging. Warwick's main mast would have had somewhere between 4 to 8 shrouds, a pairing of swifters, and 2 to 4 tackles set up. And this all depended on her size. So once we know that, we will be able to fully reconstruct her rig plan. Shrouds are long, heavy ropes that are looped over the top of the mast at the trestle trees. They come down and they connect to a series of deadeyes. The rope is strapped around the deadeye here, and it works in a deadeye pair. You see, we have one here and another that is strapped to a deadeye that is set in a chain plate. A lanyard is rove between these two so that you can pull them tight and put tension on the shrouds, very much like you were tying your shoes. They just lace up. The chain plates then take all this force that you acquire by heavily tensioning the shrouds, and they transfer it to the hull. And they set usually in a channel or a chain whale here and bolted into the lower whale. Warwick's chain plates in particular are very, very interesting. We do not have many examples of 17th century chain plates. And they are beautiful and completely preserved intact, and as someone who had to lift these off the bottom of the ocean, I can say also very heavy. So hopefully we'll be able to conserve these in the future. Now, a chain plate has several portions. One, you have a strap. It's sort of shaped like a gourd that wraps around the deadeye. It would have been hammered shut around it, and then that is connected here to the chain plate itself. You can see over here, we have a good idea of how the plate comes down and has a hook over, and it latches into the bottom of this deadeye strap. And so we have deadeye strap, chain plate, and then a bolt where it is connected to the whale. Here's an example of some chain plates off the 1686 La Belle. I also had a chance to work on the conservation of this plate here, and they're very, very, very similar. Once again, you see you have this sort of gourd-shaped deadeye strap, a plate that connects and loops over the ring there. So, however, we have these two chain plates that are some 70 years apart, but there's quite a lot of variation in chain plates at this time. You have both chain plates that themselves are plates, and then you have chain plates that are chain link. So we see both these forms at the time. If we go back and look at Mary Rose, we can see the chain link version. You have one of Mary Rose's deadeyes here. It's 7 holes. It's the earlier 16th century, sort of elongated, many, many holes. And the loop comes down here, connects to a small ring, and then a series of chains. Here you can see them set along the channel. And so we see also John Smith describes chain plates as strong plates of iron fast bolted into the ship's sides. And this is in the 1627 version of a seaman's grammar. He doesn't mention chains at all, but it's kind of interesting because both Sea Venture, which sank 10 years before Warwick, and Batavia, which sank 10 years after Warwick, they carried chains in their chain plates. And John Adams has assured me that somewhere he has a slide of those chains, but I haven't gotten my fingers on it yet. I'm going to show a lot of pictures of both Bell and Vasa because they had plates that were very, very similar to Warwick's. They both have what are fairly loose straps. The plate is connected to the whale here, comes up, sets into the channel, and the deadeye is loosely connected to the part of the chain plate which sticks above the channel. The channel here, or chain whale, it's used to spread the shrouds and swifters and tackle outboard of the ship so that they don't go against the side. You'd see in the mizzenmast channel would be much, much smaller, but you can see there's a fairly substantial piece of wood, and the plates here come up, pass through, and then they are hooked off. We see sort of also tackle rings here. And so we may have one from Warwick, though I can't be sure that this is a part of the rigging system at that point. It could be also associated with gun carriages or other things. Mary Rose's chain whale it comes here, and you see that the links do not pass through; they actually push on the outside of the channel. This is a sort of a form that disappears in the 17th century. If we look at the Dutch church model, another way to arrange these was that you would have the deadeye strap actually go down through the channel and connect underneath. So the bottom of that gourd-shaped loop would stick down through the channel, and you link it off on the bottom side. If you have that scenario, that holds the deadeye up straight and strong in the position. Now, if we look at Vasa, these deadeyes, if you get rid of the lanyards here, they'll just flop over. You see the same thing in the Norse glove model, which is the basis on which Vasa's chain plates were partly reconstructed. And you see the same situation also in La Belle. If we disconnect the lanyards, the heads will fall over. In the case of Belle, this is very much what happened. The chain plates and the deadeye straps were found concreted in position, flopped over. This is a good indication that they were loose at some point, the lanyards disconnected, and they concreted in that position. Also, in the case of Belle, we see that the neck of the plate itself has no concretion where the wood channel would have been. I cite this example because we had the exact same sort of thing on Warwick. We see that the heads, the deadeye straps of the chain plates are fallen over and concreted at a number of different angles. If the deadeye strap itself had been sitting in the channel, then it would not have been able to fall over and concrete in this position. So you can see the different ways that each one of these heads has ultimately fallen over. To give you some sort of idea of what these chain plates would look like when they were fixed to the side of the ship, we can see in the bends of the chain plate we have a flat area here that would have been pressed against the side of the whale. Then the chain plate angles out until once again it corrects, and this is the section that would have pressed against the channel so that the ship would have looked something like this. Now, we have two that were in position, and one of these has a rotated deadeye strap. Now, this would, as far as I can tell, and if someone would like to correct me on this later, this is only possible if the deadeye was missing before this concreted into position. So I don't know if this was removed or broken or just degraded first and then ultimately just concreted into this sort of irregular position. We also see similar sort of things on the Sovereign model from 1637. So we have a really good idea of what Warwick's chain plates were configured as. Now, we found two, which I originally was super excited about because I thought that they had been concreted in position. And it turned out that they were concreted and attached to the side of the hull, but they were completely upside down. So as far as we can tell, our working hypothesis at this time is that the lanyards were disconnected, the loosely set chain plates were able to swing down, pivoting on their bolt, and then concreted exactly upside down next to the hull. I don't think they were just randomly in place, partly because they were so well attached, and also because they were both regularly spaced directly in line with the second funnels, as you can see here. So in sort of fitting out, we don't have the deadeyes that fit into any of these deadeye straps, but we found a number of other deadeyes on the rack, and looking at them in scale here, you can see that these are very, very close matches to what this would be. Now, each one of these deadeyes we know was used with a rope because it has a curved channel around the outside of the deadeye. This was used for stropping. Had it had a more rectangular channel, it would have been probably designed to have the deadeye strap beat and close around it. One second. The 17th century deadeye, and more specifically the early 17th century deadeye, was sort of in a transitional stage. We see sort of a teardrop shape, though it's not very elongated. There are three holes and they have flat faces. If we look at deadeyes at either end of the spectrum, this one here is from Vasa, though it actually dates to the 16th century. It was a curated deadeye that was used at older times and gives us a kind of a good idea, an elongated teardrop shape with multiple holes in it. At the sort of end of the 17th century, we are looking at this very round-shaped deadeye. The face of it is much curved instead of being flat. So we can sort of get an idea of this sort of evolutionary process in the middle. If we go and look at Mary Rose, we see these very, very large, elongated deadeyes that from 1545, and 7 holes here, and they look very, very close to some of the deadeyes that were found on Warwick. Here, this is one of our 6-hole deadeyes, and you can see that they have almost the exact same shape. However, I don't believe that they were used for the standing rigging, and I'll explain that a little bit more. If we look moving into the middle of the 17th century, let's look at some of Vasa's deadeyes. Now we see that this sort of teardrop shape is getting sort of squashed down. It becomes a little more angular. and this face remains flat. And we also have, once again, the curated deadeye. As we move into the late century, 17th century, we see that the deadeyes from vessels like Cronin and also the Bartholomew wreck and Bell all have this sort of much rounder shape to them, and eventually receive the curved face, which will become practically universal. Now, if we look at Warwick's assemblage, we see a lot of all these shapes. We see shapes that are similar to Mary Rose, shapes that are similar to those deadeyes on Vasa. We see the sort of early 17th century teardrop shape, and we also have a rounder deadeye, though its face is still flat. Of these items, the most significant are probably the 6-hole deadeyes. And we have to kind of figure out where do these belong in the rigging plan. I don't believe they were used for the standing rigging. If we look at the chain plate that one of the in situ chain plate straps that we suppose was probably for the mainmast rigging, it's much, much smaller than either of these deadeyes. So they weren't used for standing rigging. It's more likely that they were used for the stays. English ships, the stay would be looped over the cross trees here, come down and end in a deadeye here. A lanyard would be rove between a second deadeye, which would be put on a collar and fastened around the bowsprit or wherever, depending on which mast you're working with. The stay pulls the mast forward, if you remember. We see in both like the colonial model, English ships of this period often use 5-hole deadeyes on their stays. And just down the road from Warwick, in the reconstructed Deliverance model, they chose to use a 5-hole deadeye in the stay construction of that. In the 17th century, however, we see a transition in English vessels from using deadeyes on stays to using heart blocks. And on continental vessels, this transition also includes blocks, and so there's, depending on the origin of the ship, you get different combinations of these at different dates. So it is possible that Warwick's 2 deadeyes made the part of a deadeye pair and functioned together. They are a bit of different size, but if Mary Rose is any indication, the deadeye pairings that we know were pairings from Mary Rose, the individual deadeyes had sort of a wide range of size and dimension. So it may also be that they are from different stays. There is a 9-hole deadeye, apparently, that was discovered by Tucker. However, nothing of it survives. These aren't actually pieces, just illustrative. It's unfortunate that that deadeye was not recovered or recorded in any way, but it probably would have been for the mainmast stay. And another thing to keep in mind when we look at the deadeyes from the collection of Warwick, that these things, they changed in pattern, and we can track their evolution, but they really didn't go out of style. And a piece of wood with 3 holes through it works in the 16th century, it's going to work in the 17th century. So you see a lot of examples of deadeyes being curated on ships. We see this on Vasa, where a number of 16th century vessels in a brand new ship were stowed in the rigging locker and to be used because they were probably cheap or accessible. We also see the case of La Belle, where the crew had harvested a number of rigging elements, including deadeyes, from La Amiable when it sank. Moving on to some more of the wooden artifacts, let's take a look at the blocks. Now, blocks are usually used in pulley systems, and they really didn't change much through time. These blocks here are from the Mary Rose, and they they're made out of a shell here that has a channel cut through it and a pin put through it that sits in it. A strap is wrapped around the outside of the block. And over time, they didn't change very much. We don't really have much left from Warwick. We just have these few pieces here. Thankfully, we are blessed to the fact that they have enough of them that we can use them to fully reconstruct the shape of Warwick's original blocks. But these would have come in, the ship would have had all sorts of blocks, whether they be shoe blocks, shear blocks, snatch blocks, and many, many other types. But hopefully we'll be able to get some information out of these when we finish the analysis. Really, the only difference between the blocks found on Warwick and Mary Rose is if you look at the top of the block here, there are 2 holes driven through it so that the strop could come out. In the 17th century, Warwick shows us that this system is no longer in place and the strop just wraps around and is tied off at the top. So a lot of Warwick's artifacts need serious reconservation. After they were raised in 1789 and 80, they were conserved in a variety of methods. Some used peg, some used sucrose, and some used peg with freeze drying. Now, over time, they've been kept in a variety of different conditions where humidity would fluctuate and temperature would also fluctuate, and we get both sugar and salt leaching. Texas A&M student Karen Martindale is currently involved in the reconservation process of these. She has taken a number of small wooden samples, prepared them in the same way that these were once conserved, and then subjected them to both hot, humid, and cold, dry weathering. We see in these samples that they exhibit leaching just like the leaching of sucrose and leaching of wax, just like the ones from Warwick. She then cleaned them, subjected them to baths of water and acetone, and tested both acetone rosin, MTMS, and silicon oil as different conservation techniques. These results are being submitted to the National Museum of Bermuda, and hopefully we can get these artifacts conserved so I can do some research on them and get some nice, accurate measurements. So there's not a ton of data that comes from Warwick. So what can we do with it? Well, one option is that we can do a reconstruction. And this is very practical when you have a lot of information, like hundreds of rigging elements that were found in Vaso, or you have a ship in the case, like Vaso or Mary Rose or Bell. In our case, this is going to rely a lot more on conjecture. We can take the little data that we have from the artifacts and we compare it with rigging treatises like that of the 1625 treatise on rigging, or Matthew Baker's fragments of ancient English shipwriting. And we can build sort of conjecture on conjecture. Now, all these are very hypothetical tasks. I think they do have a purpose, in that we can take the rigging elements that we've found and put them in the spatial context of the rig plan itself. And I think that'll be very useful into communicating how these things were used and to show them in place. I think the more valuable component that Warwick's rigging elements provide is that in terms of typology. I think we've added extraordinarily to the data set with these chain plates, and hopefully with a few more data points from other wrecks, we can get an idea about the evolution of chain plates over time and how both chains and the plates themselves were used at different time periods. Similarly, I think Warwick really contributes to the overall picture of dead-eye typology. We have some very closely dated wreck. We know when it sank, and so we have some very important data points about how dead-eyes are changing. And these are things that can be used to give at least a general date for ships that are found at other sites. So it's a very small assemblage. However, I think it's very important, and I think that we can get a lot from it in terms of typology. I would like to thank our entire team, especially Dr. Katie and Dr. Piotr. They have been absolutely amazingly supportive in all my research. Also, Mike Gilbert, who's been with me from the beginning. And I'd also like to thank all the professors and who have come, Dr. Nigel Niling, Dr. Edward Harris, Dr. Emily Rose, Dr. John Adams, Dr. Kevin Chrisman, Dr. Bacharov. It's been incredible to get a chance to work with them and study. And I would also like to thank all the supporting institutions that made this research possible, particularly AMARI, which made it possible for me to be here today. And one last thank you to BIOS, who brought their students out to our site and allowed us to engage them and get a lot of young scientists interested in doing archaeology. Thank you very much.